Good morning, welcome to Videos Online Academic Tutorial. Thanks for watching our YouTube videos online. Please, if you have not yet subscribed to this YouTube channel, do well to press the subscribe button now and the notification bell in order to receive all of our educative videos online. Thank you and God bless you. Remember to like this video, share with your friends, and drop your comments so as to know where to serve you more better. Thank you and God bless you. Today we are going to be considering organic chemistry under the topic called isomerism. Isomerism. We are talking about isomerism. The word isomerism comes from what? From the root word called isomers. The word isomerism comes from the root word called isomers. It comes from the root word called isomers. Now we are talking about isomers. What do you mean by isomers? Isomers are compounds which have the same molecular formula but different structure. It's a compound. Isomers are compounds which have the same molecular formula but different structure. Example of isomers is butane. Now we are talking about butane. Butane belongs to the family of alkane group. Butane belongs to the family of what? Alkane group, which has the general formula of CN H2N plus what? 2. Now, butane is what? Is number 4. That is, it has 4 carbon. Butane has 4 carbon. So which means our N is equal to what? 2 here. So if I want to write the molecular formula for butane now, so my N will be what? My N will be 4 because but is 4. So if I want to write the molecular formula for what? For butane, it will be what? C4 H what? H 2 times 4, it's going to give me 8 plus 2. So it will be C4 H10. So this is the molecular formula of what? Butane. The molecular formula of butane is what? Is C4 H10. But this butane we are talking about can be what? Can be written in terms of structure, can be written in 2 ways. That is, butane has 2 what? Isomers. And what are the 2 structures that butane have, even though they have the same molecular formula of C4 H what? H10. Now let's first draw the 2 isomers of what? Of butane. Now what are the 2 isomers of butane? Which is C4 H what? 10. Now the butane has what? Has 4 what? 4 carbon. So it means that we are going to write carbon, 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 carbon. So now, and what? And it has 10 hydrogen. So each carbon is surrounded by what? 4 bonds. 1, 2, 3, 4. So this one has already have 2. You put one here, put one here, you put one here, put one here. This one has already have 1. It's connected to 1 already. You put 3 there. 1, 2, 1, 2, 3. So you fill it up with what? Hydrogen. Fill it up with what? Hydrogen. So I won't fill it up with hydrogen. You must have what? 10 hydrogen altogether. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you can see it is C4 H10. But this butane can be written in another what? In another form, in another structure. Butane can be rewritten in another structure, which is by breaking off this methyl group and replacing that methyl group with this H. We can bring out this methyl group and replace it with H. So meaning that we are substituting this one for this, and this one is coming what? Here. So now we are going to have this kind of structure. We are going to have C, C, C. Now the methyl group is coming here, which is CH3. The methyl group CH3 is coming here. So and I'm replacing this methyl group with H. There's an exchange. So when there's an exchange like that, now let's fill in the remaining hydrogen. We have hydrogen here, hydrogen here, hydrogen here, hydrogen here, and hydrogen here. Now, if you still can't see very well, you can still see that we still have 10 hydrogen and 4 carbon. 1, 2, 3, 4. This is 4 carbon. Now let's gather our hydrogens complete. Now H3, that is H3, that is 3 hydrogen, 4 hydrogen, 5 hydrogen, 6 hydrogen, 7 hydrogen, 8 hydrogen, 9 hydrogen, 10 hydrogen. So you can see that we still have the same number of carbon and the same number of hydrogen, but different different structure. This is called butane. Butane. It's called butane. Isomer name of this structure is called butane. But the Isomer name of this structure, when you count it, now if I number it from the back, I'm going to have 1, 2, 3. If I number it, which is from the back, I'm going to have 1, 2, 3. If I number it from what? From the front, I'm still going to have, look at this, 1, 2, 3. What am I trying to say? If I number it from the front, my substituent fall on number 2. If I number it from the back, my substituent fall on number 2. So which means that whichever the case, I'm having my methyl group is falling on what? On carbon 2. So I can just name it like that. So this is 2-methyl. So the substituent is on number carbon 2. So it is 2-methyl. Now 2-methyl what? Now what am I playing in? 1, 2, 3. So it has 3 what? Carbon, and under the family of alkane what? Alkane group, because it has single bond. So if it is having carbon 3, if you have 3 carbons and under the family of alkane, it means my parent name will be what? Propane, because pro is number 3. So the family name will be propane. That is the parent name will be what? Propane. So now we can see that butane has 2 isomers. Now isomers 1 is what? The first isomers of butane is butane itself, and the second isomers of what? Butane is what? Is the second isomers 2 is what? Is 2-methyl propane. Now this is what we call isomers. Isomers are compounds which have the same molecular what? Formula. As you can see, C4H10. This one has C4H10. This also has C4H10. But they have different structure. And this one is butane, and this one is 2-methyl propane. So that's that about what? Well, that's that about isomerism. Now, the process or the phenomenon by which compound has the same molecular formula but different what? Different structural arrangement or different structural formula is what we call what? Isomerism. The phenomenon whereby compound exhibit what? The same molecular formula but different structural what? Formula is what we call what? Isomerism. This is what we call isomerism. Now we have different types of what? Isomerism. Types of what? Types of isomerism. Types of isomerism. The first type of isomerism we are having here is positional or structural what? Isomerism. Positional or structural what? Or structural isomerism. Now, the positional or structural isomerism, what do you mean by positional or structural what? Isomerism? This is a type of isomerism that depends on the arrangement of atoms or group of atoms within a particular compound. Now, this has to do with the arrangement of atoms or group of atoms in a what? In a compound. For instance, now when we are talking about pentane, e.g., when we are talking about pentane, pentane is another what? Is another compound that belongs to alkane group, and it's having, because it is pent, it's going to have what? 5 carbon. Pent is what? 5. So it's going to have 5 carbon. So the N here, knowing that pent is 5, that is N equal to 5. And the general formula of alkane group is Cn. The general formula of alkane group is Cn H2n plus 2. So meaning that this one will be C5, 2 times N to what? 10 plus what? 2, which is C5 H what? H10. H what? H12. C5 H12. So meaning that the molecular formula of what? The molecular formula of pentane is C5 H what? 12. The molecular formula of pentane is C5 H12. Now, how do you write the what? The structure for pentane? How many isomers does pentane have? Now, the first one is what? Let's first look at the first way whereby we can write the structure of what? Pentane. We have C, 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 C. Now 1, 2, 3, 4, 5. This is the first. This is the first way of writing what? Pentane structure, and it contains how many carbon? 5 what? 5 carbon. Now let's fill in the what? The hydrogen. Now we have what? We have the hydrogen here, hydrogen here, hydrogen here, we have hydrogen here, we have hydrogen here, we have hydrogen here, also hydrogen here, we have hydrogen here, hydrogen here, hydrogen, hydrogen, hydrogen. So this is called pentane. This is the first formula. It's called pentane. In what? In common name we call it N-pentane. Common name is N-pentane. Now this is the first way of writing what? Of writing the structure of pentane. Now if I now decide to what? To cut out what? Or to break out this what? This methyl group, I can use it to replace the hydrogen, one of the hydrogen here on carbon 2. I can use it to replace one of the hydrogen here on carbon 2. So I'm substituting this methyl now for this H now. So I'm replacing this methyl for this H. So what do I have now? So if I replace it with this, I'm going to have something like this. So I'm going to have 4 carbon on a straight line. We have 4 carbon on a straight line, and I'm putting what? My substituent now, I'm bringing my what? CH3 here, and my hydrogen is coming here. So we have H. So this is now. Look at this. This still has what? This has what? This structure has what? 5 carbon. 1, 2, 3, 4, 5. And it still has what? This is carbon. This is hydrogen. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it has the same number of carbon and the same number of hydrogen, but it's different structure now. So how do I name this structure now? I will number it in such a way that I will first number it. You know that the parent name here is what? The parent name here is what? 1, 2, 3, 4. It belongs to what? The family of butane. So the family name is what? Or the parent name is what? Butane. But my substituent now is what? Is methyl. Now, how do I number it so that this methyl has the least numbering? If I count from the back, it is 1, 2. From the back, this one will be 1, 2. But from the front, it will be 1, 2, 3. So from the front, it will be 1, 2, 3. So this is the correct numbering. The one here is the correct numbering. So 1, 2. So I will go with the what? With the 2, because this is 3, this is 2. But the least numbering is 2. So I'm going with what? The 2. 2 methyl butane. 2 methyl butane. Now 1, 2. So this is 2 methyl butane. This is another way of writing what? Of writing the what? The structure of pentane. Now the last one, I can decide to what? Also take the what? The methyl here. I can decide to take the methyl here. The methyl here. Let me use another color. I decide to take the methyl here and use it to replace what? I use it to replace this what? The hydrogen here. I can decide to remove this methyl and use it to replace this hydrogen here, so as to have another what? Compound. So this methyl here can be removed, or yes, can be removed to replace this what? Hydrogen in the middle here. So I'm going to have C. Now I am having methyl here already. So the one that I'm bringing, the methyl that I'm bringing in now, I'm placing it here. So then I can fill the rest with hydrogen. So my hydrogen here is, we are still having hydrogen here, hydrogen. Now if you still count it, you still see that we have the same number of carbon. 1, 2, 3, 4, 5. So we have 5. Now we have 3 hydrogen here, 3 hydrogen making 6. 7, 8, 9, 10, 11, 12. So we can still we have the same number of hydrogen and the same number of carbon, but the name has changed and the structure has also changed. So if I want to name this one, now this one will be 1, 2. Whichever the case, if I number it from the front, from the back, it's going to be what? My substituent is going to form on carbon 2. So it will be what? 2, 2, because the first substituent is number 2, the second substituent is also number 2. So 2, 2 dimethyl, because it is 2 dimethyl. Now, my parent chain is 1, 2, 3. That is carbon, that is 3 carbon, that is propane. So it means that pentane has 3 what? Isomers. Pentane has 3 what? Isomers. The first one is pentane, the second one is 2-methyl-butane, and the last one is 2,2-dimethyl what? Propane. So this is an example on positional or structural isomers. Now, another one is another example on positional and what? Another example of what? Another example, example 2. Another example 2. Example of positional what? Or structural what? Isomerism 2. So we have the second example we can consider is butane what? Butane 2-O. Now when talking about butanol, we can also consider butanol. Now butanol have different what? Isomers as well. Now if I have butanol now, butanol belongs to alkanol what? Alkanol group. Now which have the general formula of CnH2n plus 1OH, where my N now is number 4. Now N equal to 4. N equal to what? 4. So we have C4. 2 times 4 is what? 2 times 4 is 8 plus 1. It's giving 9. So OH. C4H9 OH. And if I want to draw the structure or the isomers, if I want to write the isomers for what? Butanol now. Let me focus on 1, 2, 3, 4. Now, my OH can, for butan 1-O, my OH will be at what? At carbon 1. So, for butan 1-O, my H will be, my OH, which is the functional group of the what? Of the alkanol group, is going to be on what? On carbon 1. So I can now fill the rest with what? Hydrogen. Hydrogen. So that's that about that. Now, so this one is called butan 1-O, or you can call it 1-butanol. So butan 1-O, or which is also known as what? Butanol. So this is the first structure, and also I can decide to place this on what? On carbon 2. On carbon 2, I can decide to have butan 2-O, butan 2-O. So I can decide to place it as what? I can decide to place this OH at what? At butan. So I can decide to place this what? OH at what? At number what? 2. So now, and I fill the rest with what? H. So look at this now. This one is what? The number of what? The position is 1, 2. This one is butan 2-O. Butan 2-O is different from what? This one. These are another isomers in terms of what? The functional group OA. I can also decide what? To replace what? To take this OCH and bring it here to form another what? Another isomers. For example, I can use this one, I can replace this one to form another isomer, replace this one to form another. So we have what? Bring this H here and take this one here. So we have what? C. We have OH here. We have what? We have CH3 here. We have H. Now if I want to name this one, and this one is, now look at this. My parent name is now what? 1, 2, 3. How many carbon am I having? I'm having 3 carbon. So with OH now, it will now be propanol. The parent name is propanol. The parent name is propanol. Not even propanol alone, it is propan 2-O, because this is 1, 2, 3. So this is propan 2-up. That's the parent name. Now the substituent is what? The substituent is methyl and is on what? Position 2. So the IUPAC name now, the IUPAC name will now be what? The IUPAC name will now be the IUPAC what? The IUPAC name will be equal to now 2-methyl, because the position of the what? Methyl is what? Is about 2-methyl propan 2-up. So this is another way of writing what? Butanol. In another, this is another isomers of what? Butanol. Other possible isomers that we can have in what? In butanol is when I replace this CH what? When I take this CH3 and use it to what? To replace this what? Hydrogen here. So I can also have another one which is called 2-methyl-butan 1-up. Let's do it. I'm using this H now to replace this. So I'm having how many C? C 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. So we have what? 1, 2, 3. So 1, 2, 3. So I'm replacing now this H now with this. So we have what? CH3 here, and the H comes here. So we fill in the rest with H. And don't forget that the OH is also here. So we have H. Now, this is another way of. So this one will now be what? Look at this one. The parent name is what? 1, 2, 3. So propanol. But this propanol is propan 1-up because the OH is on what? On carbon 1. So this is propan 1-up. That is what? Propan 1-up. That is the parent what? Parent name. That's the parent name. That's the parent name. Now, so now if I want to name this one, the parent name here is what? The parent name here is 1, 2, 3. Propan. Now, this is on position 1. This OH is on position 1, so propan 1-up. Now, the substituent is 1, 2. So, the substituent here is methyl. So, and the position of that methyl is 2. So, it's 2-methyl. 2-methyl. So, now, combining it together to have the IUPAC name, we have what? This one will be what? 2-methyl propan 1-up. So this is another isomer. This is another possible isomers in butanol. So meaning that if I want to write butanol now, I can write butanol in these 3 words, in these 4 isomers. So that on what? On positional isomerism. The second type of isomerism we are having is geometric what? Geometric isomerism. Now we are talking about geometric isomerism. What do you mean by geometric isomerism? Geometric isomerism is a cis-trans isomerism. Geometric isomerism is a cis-trans what? Isomerism. It's a cis-trans what? Isomerism. That is, geometric isomerism has 2 forms. It can be cis, it can be what? Trans. Geometrical isomerism usually form in what? In alkenes and cyclic hydrocarbon. Now, I come again. Geometrical isomerism is a cis-trans what? Isomerism, and usually found in what? In alkenes and cyclic what? Hydrocarbon. For instance, now, in what? For examples. Now, for example, now the cis isomers, we can find the example in what? In what? C double bond what? C double bond C, and we have chlorine on one side, and you have hydrogen on one side. Now, we have this an alkene what? Alkene group. You can see an alkene group having double bond. Now, when I talk about alkene group is an hydrocarbon with carbon-carbon double bond. So, yeah. So now, this is a alkene group having double bond, and look at this, the chlorine here is on one side and the hydrogen here is another one, it's another side. So we call this one cis because the same atom is on the one side, the same atom is on one side. So we have what? We have, if I want to name this one now, we call it cis now 1 and 2. Because chlorine is on number 1, it's on number 2. Cis 1, 2, dichloro. Now because it is 2 chloro. Now this is what? This is, it contains 2 carbons, so it is Lt. So now why is it cis? It's because the chloro, the what? The same atom is on one side of the compound. So we call that type of isomer cis isomers. We have trans isomers, which is another type of what? Trans isomer, another type of geometric isomerism that we have. Another type of geometric isomerism that we have. Now, for instance, now when we now have this what? C double bond Cl here, and we have hydrogen here. Hydrogen what? Hydrogen here. Now, in this situation now, we have chlorine to be on the opposite side. There is one chlorine on this side and there is another chlorine here on this side. We call it trans. So this is trans 1, 2 dichloro dichloroethene. So this dichloroethene. So this is a trans what? Isomerism. And also we can also find this in what? In cyclic hydrocarbon, such as when you have something like this. This is bromo, and you have what? This is just showing the spatial arrangement of what? Of the atom. So this is indicating the spatial. Now, for instance, now you want to name this one now. This is a what? This is a cyclo compound. You have this is cycloalkane, which is cyclo. This is cyclobutane. And you want to number this one, and this one is. I can just start numbering from what? This bromo. We have what? We have. I want to name this. This is 1, 2, 3, 4. Now, because this is bromo now, this is bromo. Bromo comes before chloro, so in alphabetical order. So we have 1 bromo, 3, 1 bromo, 3, 1 bromo, 3 chloro, cyclo. 1, 2, 3, 4. The cyclo is for the cyclic, so the cyclobutane, because this carbon cyclobutane. So this is also a trans. It's also trans as well. You can see it's in opposite side. Now this is under what? Geometrical what? Isomerism. Now the third type of what? Geometrical isomerism that we're having is called optical what? Optical isomerism. When I'm talking about optical isomerism, what do you mean by optical isomerism? Optical isomerism is observed in a molecules where 4 different atoms or 4 different group of atoms is attached to a single carbon. Is attached when 4 different group of atoms is attached to a single carbon, to only one carbon, we have optical what? Isomerism. For instance, now when I'm talking about optical isomerism, when you are talking about butane, in butane 2-O. Now let's check what do you mean by butane 2-O. Let's write it. Let's try to write it. Butane 2-O. It means that it has the functional group here is O, and the position of that O is on number 2. So but is having what? 4 carbon. Now 4 carbon. So we're having 4 carbon now. The position of the O is, which is OH, is on the what? On carbon 2. So I'm putting OH here. So I'm filling the rest with what? Hydrogen. So I hope you are following with. So how does this butane 2-O possess what? How does it possess optical what? Isomerism. Now, this we can try to write this thing in what? In another form. How do we write it? This is combine and compress this together. When you compress CH what? This is CH3, CH2, which is known as what? This is This is a T group. This is a T what? A T group. This is LT, which is a substituent. This is another what? This is another group here, OH. This is another what? This is another group here, which is MET. And this is another what? So you can see we have LT, hydroxy, MET, and we have what? We have H here. It's connected to what? One carbon. If I want to write it in a compressed form now, I'm going to have what? C2H5 connected to what? C. We have H. We have what? We have OH in the what? Below. And we have CH what? CH what? 3. Now, this is an optical what? Isomerism. This is an example of optical what? Optical isomerism. So optical what? Isomerism. And this optical isomerism, they possess mirror image. They have mirror image. It means they are what? They are not superimposable on one another. When I'm talking about mirror image, they cannot be placed on one another. For example, now if I place this one, when I place this molecule in front of the mirror, what do I have? When I place this molecule in front of the mirror, like this CH3, OH, then we have C2H5. Now what do I have? If assuming this is my mirror, this is my mirror here, what I'm going to have here is this I'm going to have CH3 here, the CH3, and I'm going to have C2H5 here, I'm going to have OH here, I'm going to have what? H rather, I'm going to have H here, and then OH. So you can see that the CH3 now is now appearing, the CH3 is now appearing here, and the C2H5 is now appearing here. So this is what we call what? Mirror image. That is, and this cannot be superimposed, that is cannot be placed on this, because it gives us now, we now have C2H5 here, and we have CH3 what? CH3 here. So that's why we call it what? They are what? They cannot be superimposed, and we call such isomers. These two isomers are called what? Enantiomers. The two isomers form. The isomers from what? The isomers from optical isomerism are called enantiomers. Enantiomers. They are called enantiomers. And as you can see that it has the center what? Carbon. The center carbon where all other atoms are attached to, and that carbon is called chiral carbon. We can call this center carbon chiral what? Chiral carbon. Carbon at the center. The carbon at the center is called chiral what? Chiral what? Carbon. The carbon at the center is called chiral carbon, also known as what? Also known as the optical what? Center. This is for just the objective. So in such a situation now, we have what? We have the carbon here. This is the middle one. This is the carbon. This is the optical center whereby all other atoms is being attached to. So that's that. Another example is when you have what? Another example is bromo chloro fluoro methane. Now when you this is another example, bromo chloro fluoro butane methane. So when you have C and you have maybe you have what? Chloro here, you have bromo, you have hydrogen, and you have fluoro here. So in such a situation now, when you place mirror on this, you are going to have C. This is your mirror, this is your mirror here. What are you going to have? You are going to have bromo coming to this place, and this one chloro, and we are having hydrogen still maintain its position. You can see now this is what we call another what? optical what? Isomers. You can see these are optical isomers and optical isomers. So, and these are the types of what? Isomerism that we have. These are the type of isomerism. Now let's go to what? To the Jamb questions before us. The question we are having here under the solution to what? To Jamb and Waec question under isomerism is now look at this. They said this is a structure. We are given a structure A and structure what? B. Now a property common to the structure above is that they have the same what? Now look at the structure. Look at the structure. What is the property common to the structure above? We can see that you have C. How many C we have? 1, 2, 3, 4, 5. We also have 1, 2, 3, 4, 5. Now they have. Now what is common to the structure above? You can see that they have the same number of carbon and the same number of what? Hydrogen. So they have the same molecular formula. You can see that this, because they have the same number of carbon and the same number of what? Hydrogen. They have the same molecular what? Same molecular formula. Now let's look at this. But the structure are different. Look at this. This one is the metal is attached to the straight chain of this, and this one is just a what? A straight chain. This is a straight chain. This is a straight chain hydrocarbon. Straight chain hydrocarbon. This is a branch what? Branch chain hydrocarbon. Now you can see that there are two different things in terms of structure. They have the same molecular what? Formula. They have the same carbon, which is what? Carbon C. They have the same carbon, which is carbon C. Here is 5. And hydrogen is what? I think it's 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This is 12. So now they have the same molecular formula, which is what? C5H12, but different what? Structural, which is straight chain hydrocarbon and branch chain what? Hydrocarbon. So now let's look at the option that fits in the same molecular what? Formula, but different what? Different structural what? Formula. Different structural formula. So the option should be what? Structural, the same structural and molecular formula, no. The same structural formula but different molecular formula, no. Number of carbon but different molecular mass, no. They must have the same molecular mass, the same molecular mass, they must have the same molecular masses, they have the same molecular formula. So now let's look at the molecular formula but different what? The same molecular formula but different what? Structural formula. Yes, the same molecular formula but different structural formula. Option what? D. So now see the application of what we just did now. Now, geometric what? Isomerism can exist in what? Geometric isomerism can exist in what? Geometric isomerism can exist in. Now, we are talking about geometric isomerism. Geometric isomerism occur in alkene group. Agreeing what? Alkene group. So, geometric isomerism occurs in what? In alkene group. Now, although it also occurs in cyclic what? Hydrocarbon bond, majorly for one level is alkene what? Alkene group. Now you begin to look for alkene group. So now B is not even an option now for us to consider because it's a single what? Carbon organic compound which is alkane. Now let's check what? S3 what? In. X3 in. S3 in is what? Is a family of alkene groups. So X3 in. Let's consider X3 in. X3 in. X3 in. How do you write X3 in? X3 in is C. Let's consider S3 in. Let me write it there. X3 in. Now, I'm talking about X3 in. How can we draw the structure? How does it comply with geometric what? Isomerism. Now we talk about geometrical isomerism. We are talking about the cis trans what? Isomerism. And this one we're using in terms of what? Cis and trans. Now let's try and write what? X3. Now that's 6. This is 6. 6 carbon. Now let's draw 6. 1, 2, 3, 4, 5, and 6. Now the position of the in, which is double bond, is on number what? 3. Now, so it means that 1, 2, 3. So this double bond in the air. So you can fill the rest with what? Hydrogen. So we are having hydrogen hydrogen here. Let me clean, this is 6 carbon, hydrogen here. We are having hydrogen here, hydrogen here, hydrogen here, hydrogen here. No, just one hydrogen because this is 1, 2, 3, 4. So another hydrogen here, hydrogen here, hydrogen here, hydrogen here. So this is X what? 3 in. Now can this one exhibit what? Can this exhibit 6 isomers? Now let's see, when you compress this together and you compress this together, so this one is LT. So we can have C double bond C. Now the hydrogen here is this. Compress this one together now, we have C2H what? 5. That's why it can connect with your C2H what? 5, connect to the carbon. Now this one, you can also write this H up. Now this is C2H what? 5. Now you can see this is typically an example of 6. This is 6 isomers. Now we can see this is 6 isomers. This is 6 isomers, and it can also be written in what trans. You can put H here, put what? H here, put C2H5 here, and put C2H5 here. This one will be what? This one will be trans what? This one will be trans. This one will be trans isomer. So we can see that the first, we can see that the exit can exhibit what? This can exhibit what? Geometry what? Exit exhibits geometric what? Isomers, since it what? Exhibits geometric what? Isomerism. Because it can be written in form of 6 isomers and trans isomers. So the option is what? Option A. Hexane does not have what? Because hexane cannot exhibit because it is not what? An alkene group. Prop 1 cannot. Why does propane cannot exhibit what? Why does propane cannot exhibit geometrical isomer? Because propane has odd number of what? It has odd number of carbon. It has odd number of carbon. For example, now, for instance, now we are talking about prop 1 in. It means that it has 3 carbon. That is, and 3 is odd. And 3 is odd. The third one here is here. So you cannot. There's no how you can what? You can have what? There's no how you can have geometrical isomerism there because the compound is asymmetric what? Compound asymmetric what? Asymmetric what? Alkenes. This is asymmetric what? Alkenes. Because when you divide it now into 2 halves, we are having C here, we are having what? 1 C here, we are having what? 2 C here. So you can see that you can easily divide this one into 2. This is symmetrical what? Alkenes. So that's why another thing that you need to know is that geometrical isomerism occur in what? In symmetrical what? Symmetrical what? Alkenes. Geometrical isomerism occur in symmetrical what? Alkenes. Please note that. So that's why this option, this and this option here is ruled out. Although this is symmetrical alkene, but that is option of methyl. So that's why it is ruled out. So now the option here is what? X3 in. X3 in. Now the question number 3 here. Let me says question 3. The question asks us the isomers of C3H8O are what? What are the isomers of what? C3H8O. Now, how do we go about that? Now, the first thing is to try and write just the structure of C3H8O. Now, C3. Now, it has O. Now, the first possibility of this compound is to be what? OH. To have what? OH. The functional group of what? OH. It has the functional group of OH. Now I cannot fill the rest with hydrogen. Let's see whether it will comply with the molecular formula. Now you can see that, let's count how many hydrogen I have. 1, 2, 3, 4, 5, 6, 7, 8. This is 8. And I'm having one oxygen, so I'm having what? C3 now, H8 and O what? And O. Now it's in conformity with what? With this molecular given. This is molecular given. And this is my first structure. So this means that this can exhibit what? This structure, which is normal. This is called propanol. That is propan 1 up. You can call it propanol or propan 1 up because the position of the what? Of the OH here is 1. Now I can decide to what? To bring what? The OH to this position. So if I bring it to that position, what do I have? I'm going to have C, 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 OH. So I'll fill this one with H, H. This one we have H, H. So if I want to name this one, now this one will be 1, 2, 3. So this one will be propan 2 or. So this is propan 1 or propan 2 or you can also call it what? You can also make the same thing as what? 1 propanol. You can also call it 1 propanol. Depends on you. 1 propanol. You can call it 1 propanol or 2 propan what? This one will be 2 propanol. So, but I prefer using propan 2 up. Now look at this. So which one is our option here? 1 propanol and no. You cannot write this one as propanol because one hydrogen will be missing. Now, so now let's look at this. Let's look at this. Which one is the option? 2 propanol and 1 propanol and 2 propanol. That's option what? Option A. Option A. So that's that about what? That. Now let's go to question number 4. Question number 4 says CH3. You can see it. This is question number 4. Question number 4 is given as what? CH3. We have carbon here, bonding with hydrogen, bonding with what? COOH, and we have OH now. Now, this is a structure given to us. Now, if you look at this structure very well, look at this. This 4 atom here, 1, 2, 3, 4, is connected to what? This 4 atom is connected to 1, this another one, is connected to one carbon here. So such isomerism is called optical what? Isomerism. When we are talking about 4 different atoms attaching to one carbon, we call that what? Optical what? Isomerism. And this is called what? This is called optical what? Isomers. This is an optical isomers. And it possesses what? It possesses a mirror what? Image and cannot be superimposed on one another. This is an optical isomer. So it's an optical what? Isomerism. So the compound is bit what? Optical isomerism. Option what? Option B. Optical isomerism. Now consider what? This is a Waec question. Consider number 5 question now. We are asked to consider the. Here is question number what? Question number 5. Consider the following compound. Number 5. Consider the following compound. Now look at the compound A. Compound A is, we have already even talked about that today. Question number 5. The first compound given to us under question number 5 is what? Is you can see this is what? This is 1,2 dichloro what? This is 1,2 dichloroethene. And the carbon here, look at the carbon here. The carbon here is opposite to one another. So this is trans. And this is what? Look at this. We are having the same they are having the same. This is what? 6. This is 6 what? Which means this is a geometrical what? Isomerism. Now, what is the relationship between A and B? The relationship between A and B is that A and B exhibit what? Geometrical what? Compound A and B. Compound A and B. Exhibit what? Exhibit geometrical what? Geometrical what? Isomerism. Exhibit geometrical isomerism. Now, name each of the compound A and B. Now you want to name compound A. Compound A is 1, 2, but it is trans. Compound A is trans, so it will be trans 1, 2 dichloro. Why is it dichloro? 2 chloro. Now, how many carbon does it contain? 2 carbon. Dichloro 18. Don't forget the one. 18. Now, compound B is the same thing, but the what? Difference is just 6. 6. 1, 2. So 6, 1, 2 dichloro 18. Now, what will the chemical properties of A and B be the same? Yes, that's Roman figure what? This Roman figure 1, Roman figure 2. Will the Roman figure say will the chemical properties will be the same? Yes, the chemical properties will be the same. Yes, the chemical properties will be the same. The chemical properties will be what? Will be the same. And then Roman figure what? Roman figure 4 now. Give the reason why. Because they have the same molecular formula. They have the same number of carbon, they have the same number of hydrogen. They have the same, they have the same, because they have what? Because they have the same molecular formula. So the chemical properties will be the same thing. Nothing will happen to what? There's not going to be a difference between the chemical properties, because they are having the same molecular formula. They are having the same number of chlorine, the same number of carbon, and the same number of hydrogen. So the chemical properties will be the same. So thanks for watching today. Please remember to like the video, drop your comment, and share with your colleagues. Thank you, and God bless you. Don't forget to subscribe. See you next time.